exponential rules. What are they? So we have, it's gonna be a lesson on exponential rules. All right. Now, you probably already know that if you have an x term to a power multiplied by another x term of a power, you know that the exponents add. X to the power 3 times x to the power 5 equals x to the power 8, right? What that looks like is we have x to the power of, say, n times x to the power of m is equal to x to the power of n plus m, right? And this is called the product rule. Okay? So that's the first rule, the product rule. Label that as 1. Then we also have the opposite of the product rule. We have something called the quotient rule. Quotient rule. And that basically states that a variable divided by another variable to a power, say we have 5 and we have 8, this will equal to 5 minus 8. And that will equal to -3. A to the power of n over a to the power of m, that will equal a to the power of n minus m. Now this one is one you maybe haven't seen. It's called power of a power rule. Now what this essentially states is when you raise a power to a power, you multiply exponents. So we have a to the power of m, and then outside of that we have to the power of n. What will that equal to? Well, that will just equal to a m times n. Not the best looking m over here, but that's a little better. A times n. So let's plug some numbers into this. So we have 3 to the power of 2, and then close that. And then we have to the power of 3. What will that equal to? This will just equal to 3. We won't start by squaring the 3 and it'll be equal to 9 and then putting that to the power of 3. You'll just multiply these two and then it will be equal to 3 to the power of 6. See? The next rule is called the power of a quotient. Now, what it essentially means is, this is one of the rules where you could just spread the exponents to make, solving easier. I haven't been numbering these. Hold on. 2, 3. Where's the 4th? Never mind, I skipped it. Here. Now this one, power of a quotient. This one essentially states that if you have a over b to the power of n, that just distributes to a over b and to the power of n, both. You're able to distribute the exponent to each variable singularly. You have another tool in your toolbox. So this would be xy minus xz. Just think of it that way. Next, we have the power of a product rule. You might be noticing by now the similarity. Quotient has to do with division and power has to do with multiplication. And I'll write this one under power of a quotient rule. 5 over here. This basically just states if you have AB all to the power of n, right? You're able to, again, spread the exponent. So now it becomes bn an. So, what is this one called? It's called power of a product rule. And it's the same as power of a quotient. Just think power, it's in the name. Power, exponent, and quotient, division. And for this one, think of power, and then you have product, multiplication. Next one is, this one is just a basic rule you need to know. You maybe know this already from your other math classes or just general math, but just the zero, product, property. And this one just says anything to the power of 0. Hold up. Anything to the power of 0 is equals to 1. But say I have 674 to the power of 0. That just equals to, drum rolls please, 1. And the last one, we have some free real estate. And this one just said the negative exponent rule. And this just, hold up, let me just separate this. The negative exponent rule just says, basically, if you have a to the power of negative n, that just equals to the reciprocal of a. So it would be 1 over a positive n. This rule is extremely useful, especially when you're dealing with negative exponents like this and you don't know how to do them. So I'll do a couple problems, and for this one you would ask, how did you get a negative exponent? How would you define that? From this rule, the negative exponent rule, what would this equal to? That would equal to 1 over x over 3. X, yeah. And if x, say, was 2 to the power of 3 is just 2, 2, 4, 2, 8. It would be just 8 over 1 if x was 2. So we have 3 levels of varying difficulty. And for the first one, what rule can we apply here? We have x to the 4 times x negative squared. From our exponent rules, we know that when we're multiplying exponents, we add. So x to the power of 4, minus 2. And the answer is just x squared. For level 2, for problem 2, we raised the difficulty by just a tiny bit. You should need to know some fractional rules and you'll be fine. So we have this whole term to the power of 2. So what can we do? So we can first of all multiply everything here by 2. So 2 times 2 is, we have 4. 2 and 8 to the power of 3 will just be 2 to the power of 6. And then b times negative 1 will just be b to the power of negative 2. Now we know that all of these terms, so we have, realistically, they're all separated, but we could write it also as 4a6 times b to the negative 2, and b to the negative 2 from our exponent laws is just a reciprocal of b squared. Anytime we have a negative, we just either put it over 1, so we have xy, and then b to the negative 2. Since this is singular, it's just a b over negative 2, we take the reciprocal and we put it over 1. But over here, since b is a fractional term, it becomes b squared over xy. The reciprocal just flips the fraction or just puts it under 1. So now we just have b squared over 1 times 4a6, 6 here. And then what's left is just to multiply the fractions. Multiply this by 1. So now we're left with 4a to the power of 6 over b squared. For the third problem, so don't be afraid of this. Just always remember that to use your exponent rules, right? Use everything you have. So from here, I'm going to first start with multiply everything by 3. So that will take us to x to the power of 6, y to the power of negative 3, over x to the 4th times y squared. Now from here, we could just go and subtract, because it's x term, y term, y term. Now, since we have these x terms and y terms, now we could use what? The quotient rule. And the quotient rule basically says that 6, x to the power of 6, minus x to the 4, this equals to x squared. Now we have an x squared. Get this wrong. You might think this is negative 1. But no, it is y minus, you always subtract 2. The reason I put it in this way instead of 2 minus 3, because it would be 2 minus negative 3, and that would be positive 5. But what we have here is negative 3 first, minus 2. So this equals to y to the power of negative 5. So now what do we have? We have x squared and y to the power of negative 5. What can we do with this? First, we could place them together. X squared times y to the negative 5. We take the reciprocal, y to the 5 over 1, multiplied by x squared. Then we just multiply. We have x squared over y 5. X squared. And that's all. That's as far as we can take it down. Is to basically just simplify it into the smallest form you could do. So unless you could simplify these more, then there's nothing more to write down. We have x squared over y5. Unless we have numbers, we can't really do anything. We have 4a6 over b squared. Then we have just x squared. So if you found anything helpful here, just leave a comment on, a topic that you're struggling with or you need help. Like, subscribe,